we are talking about operations on matrices. We talk about a few operations: additions and subtraction, scalar multiplication, and multiplication. Okay. So before that, now let's introduce some terms. The size of a matrix. The size of a matrix. Uh, Now let's say the size is denoted by by that we mean how many rows and how many columns. Now let's say the matrix A on the screen, we have a matrix A with 2 rows and 3 columns. Again, that way, horizontal way is rows and the vertical ways are columns. Okay. I mentioned that because in past years some people were confused about that. And for the entries or for the elements or for the numbers in the matrices, we're going to use something like this to indicate the location. So now let's say A13, A13. If I use A to denote the given matrix, A13 is the number located in the first row and the third column. The first little one is for the number of rows. The second little number is for the number of columns. And likewise, A22 is 5. A22 is the number located in the second row, the second column. Now I want you to write something in the chat. So what would be what is A23? I'm looking for the number A23. So tell me what is A23, please. A23? Yeah, 6 is A23, right? A23 is the number located in the second row, the third column. It's 6. I think you guys got it. Okay. After you know that, then we talk about addition and subtraction first. Okay. The definition is on the next slide. Addition and the subtraction is defined on that line. By that we mean it's only possible to add two matrices when they are of the same size, when they have the same number of rows and the same number of columns. Okay. And to add two matrices, all we need is to add the corresponding entries. And also, if two matrices are in different sizes, then we say addition and subtraction are not defined, are undefined. Turn off your microphone, please, if you don't have any questions. Okay, we look at a few questions, a few examples. Okay. Again, get your handout, please. I haven't opened the handout yet. Now we are ready to talk about the handout questions. In question one, I'll try to make a little bigger. In question one, you are given 4 matrices, I believe, right? We're going to use part 1, question 1 to talk about addition and subtraction. Okay, addition in question 1, we are given 4 matrices. How about I'm going to copy the whole thing of that on PowerPoint so we have something to look at, right? Okay, simple. In question 1, we're trying to compute a plus b. Okay. Is the addition defined? By that we mean, is it possible to compute the sum of 2 matrices? the answer is called the sum is comparable to numbers. In the question, we are trying to compute a plus b. So because a and b are in the same size, so it's possible to compute the addition. To get the sum of two matrices, all we need is to add the corresponding entries, okay, elements. So people say it in different ways. We can say entries, we can say elements. The first number, the number located in the first row, the first column, you add 2 and 4, you have 6, right? It's easy. And then this number, I believe, is 2. The next number, I believe, is 5. I'm trying to say to add two matrices, all we need is to add corresponding entries, the corresponding elements. The next number, so this number is located in the second row, the first column. This number is 0, this number is 1, yeah, this number is 7, right? Easy. All we need is to add the corresponding entries. That's how we get the sum of two matrices. That's how we add two matrices. Okay. And subtraction is very similar. It's very similar. Okay. Subtraction, if we want to compute a minus b, we can say we subtract b from a. Okay. To compute a minus b, all we need is to subtract the corresponding entries. The first number is computed using 2 minus 4, okay, so which is negative 2. Second number is 0, I believe. This number is 1. 3 minus 2 is 1. Now the number located in the second row, the first column, 0. I think this number is 1. So correct me if you see anything wrong. Okay. Yeah, this number is 5. That's how we subtract two matrices. Easy, right? Okay. In addition to that, I will give you an additional question. So tell me what would be the answer to d plus f. So what's the answer to d plus f? D plus f, please. Anybody want to write the answer? The size of D is 2 by 3, 2 rows, 3 columns. F is a matrix of size 3 by 4, I believe. 3 rows and 4 columns. If I'm looking for the answer to D plus F, so please, anybody want to tell me how to answer the question? Undefined.
1, 4.
No, undefined. We cannot add or subtract two matrices in different sizes. So the answer is undefined. So because D and F are in different sizes, of different sizes, so D plus F or D minus F is undefined. Okay. Easy, right? And then we talk about how to perform one other operation. The other operation is called scalar multiplication. Scalar multiplication. In this course, C, by scalar we mean a number, a constant number. Okay. We can use a number to multiply a matrix. We can use a number to multiply a matrix. The answer is a matrix. The new matrix is computed by multiplying all the numbers in the entry by the constant c. So this is easy too. Okay. On the handout we're also trying to compute the 2a. Now we'll do question 3. Okay. 2a is a scalar multiplication. Again, the operation is called a scalar multiplication. By that we mean we can use a number to multiply a matrix. Now I'm going to include 2a in the question. I think that's question 1. Yeah, that's question 2. Okay. Now we move on to question 3. In question 3, we're trying to compute 2a scalar multiplication. Okay. 2a is computed. A is here. All we need is to multiply all the entries, all the numbers in the matrix by the scalar of 2, and then the resulting matrix is called uh, the scalar multiple. The answer is called the scalar multiple. The operation is called scalar multiplication. The answer is called scalar multiple. Okay. You just double all the entries in matrix A. I think you have 4, 2, 6, 0, 2, 2, 12, right? So that's the answer. At this point, I want to mention some terms. So now let's say, I think we can just use numbers to talk about that. If you compute a plus 2, a plus 2 is equal to 3, okay? And the operation is called addition. The operation here is called addition. And the answer is called the sum. The operation is addition, right? It's comparable to matrices. The operation is called addition. The answer is called the sum. And likewise, if I want you to multiply 2 and 3, the answer is 6, right? The operation here is called a multiplication. The answer is a product. But for scalar multiplication, we do not call it the product. We call it a scalar multiple. Yeah, that's the name. Okay. I think we can also call 6 2 multiples of 3. Okay, it's comparable to that. Okay. We have introduced 3 operations: addition, subtraction, and scalar multiplication. All these 3 are simple, very simple, actually. Okay. So just remember, when the 2 matrices are of different sizes, it's not possible to add or subtract 2 matrices. The answer would be undefined. Okay. The next thing we are going to learn is a little bit complicated. It's called multiplication. So basically, we want to learn how to multiply 2 matrices. Later on, you're going to see a multiplication is not commutative. It's not comparable to numbers. For any numbers, 2 times 3 is always the same thing as 3 times 2. For multiplication of all the multiplication for numbers are commutative. We say the property is commutative. Later on, you're going to see, I want you to remember now, matrix multiplication is not commutative. Later on, we are going to define the meaning of A times B. You are going to see if you compute A times B, in almost all the cases, it's not the same as B times A. So in this case, we say matrix multiplication, the operation is not commutative. Okay, you are going to see why later. But now we move on to the definition. We move on to the definition. The first thing we do is to talk about how to multiply a row matrix and a column matrix. By a row matrix, we mean in the matrix there's only one row. There's only one row. I mean, yeah, there's only one row. Okay. Now let's say A is a row matrix. A row matrix. There could be many columns. A is a row matrix, and likewise B is a column matrix. Before we talk about how to define multiplication on matrices in general, we talk about how to multiply a row matrix and a column matrix. In the future, I just say how to multiply a row and a column. The definition is on the screen. It's only possible to multiply a row matrix and a column matrix when the two matrices have the same number of entries. I'm going to make more comments on that. And the answer is defined on the screen. You multiply the corresponding numbers and then you add all the sum, all the products. I will show you what I mean using some particular questions. Okay. Now, for example, I'm making comments on how to multiply a row and a column. Now, for example, if I give you two matrices, so now let's say A is a row matrix. So now let's say 1, 2, 3. And by the way, so do not add commas between the numbers in matrices. It's a convention. A is a row matrix. Okay. If I give you a column matrix, B is a column matrix. The matrix has only one column. So whatever number you want. So now let's say 2, 1, -2. I do not want to make the numbers too complicated. Okay. Then it's possible to compute a row matrix and a column matrix. The row has to be on the left, the column has to be on the right. If that's the case, A times B, you do not have to use any notations in between. So do not write dot, do not write cross. I want to repeat, to multiply two matrices, the standard notation is you do not write anything in between. If you do not write anything in between, it means a multiplication. I'm trying to say, do not write a dot, do not write a cross. I'm trying to say, so do not write A dot B. The meaning of that is different. Do not write A cross B. So do not write that either. Okay. If A is a row matrix, B is a column matrix, you have to write B on the left. Sorry, I said something wrong. You have to write A on the left. You have to write B on the right. Later on, you are going to see why. The answer to that is a number. The answer to the product of AB is a number when A is a row matrix, when B is a column matrix. The number is computed using the first number in the row matrix times the first number in the column matrix. I mean 1 times 2. This dot, it means we multiply two numbers. That's a number operation. Okay. And then you multiply the second entry in the row matrix and the second number in the column matrix. 2 times 1. And then plus 3 times -2. The answer is a number. The answer is a number. You see the answer as a number. So anybody want to tell me the answer? I think it's 4 minus 6. I think the answer is -2. Is that right?
-2.
Yeah, -2. Thank you. That's how we multiply a row and a column. That's how we multiply a row matrix and a column matrix. So later on, we are going to use this. We are going to use that to define how we multiply two matrices in general. If I give you another matrix C, so now let's say C is a column matrix with two entries, or 2 by 1 matrix. So now let's say 1, 2. If I want you to compute the product of A and C, if I want you to multiply A and C, what would be the answer? Anybody want to tell me the answer? A has three numbers, a row matrix. Undefined. Undefined is right. Okay. A times C is undefined. We do not define the product of two matrices like that. Undefined. Good enough? We just mentioned how to, we just learned how to compute a row and a column, how to compute a row matrix and how to multiply a row matrix and a column matrix. Now we are ready to move on to the general definition. At this point, I cannot tell you why the matrix multiplication is defined that way. But in later chapters, when we talk about the composition of linear transformations, of linear maps, then I'm going to tell you why the matrix multiplication is defined that way. And probably it's easier if I copy the definition on PowerPoint so I can make some comments. I think it's possible to see it. Okay. And also, I will use two particular matrices to talk about the meaning, in the definition. I'm going to squeeze A and B here. Okay. Now we're going to define the product of A and B. The product of A and B. I told you earlier, in general, matrix multiplication is not commutative, so it's important to mention which matrix is on the left and which matrix is on the right. Now we consider A as the matrix on the left. We consider B as the matrix on the right. We are trying to define the product of A and B. We are trying to define that. Okay. Now let's look at the definition. You need to answer three questions. The first question is the product defined? Is the product defined? The condition you need to check is in condition 1. You check how many columns in A, and then you check how many rows in B. How many columns in A? You can write it on the chat. There are 3 columns in A, right? There are 3 columns in A. How many rows in B? There are 3 rows in B. Okay. When the number of columns in A, when the number of columns in the matrix on the left is the same as the number of rows in the matrix on the right, then the product is defined. So firstly, A times B is defined, right? So because there are 3 columns in A in the matrix on the left, there are 3 rows in B in the matrix on the right. It's defined. Later on, I'm going to give you a simpler way to see if the product is defined or not. But now you remember the definition. Only when the number of columns in A, the matrix on the left, is the same as the number of rows in B, the matrix on the right, only in that case, AB is defined. the product is defined. So how about I'm going to tell you the simpler way right now. Okay. Now the simpler way, okay. For A, you write down the size of the matrix. By that we mean how many rows, how many columns. A is a 2 by 3 matrix, right? A is a 2 by 3 matrix. We're trying to define, I'm still talking about item number 1. I mean condition 1. A is a 2 by 3 matrix. You could imagine the size. You do not have to write that down. You could imagine the size. And the B is the matrix. The size of the matrix B is 3 by 2, 3 rows and 2 columns, right? 3 by 2. This time I said by. Under what condition? Under what condition the product is defined? You look at these two numbers. You look at the two middle numbers. You look at these two numbers. Does the number of rows in matrix A, I said something wrong. I'll start over. Does the number of columns in matrix A, does the number of rows in column B? You check these two numbers. If these two numbers are the same, then the product is defined. AB is defined. Okay. Simple enough. One additional question. Anybody want to tell me, is BA defined? Is BA defined? I will squeeze that in here. Is BA defined? The matrix B, again, the size of matrix B is 3 by 2, right? And the size of A is 2 by 3. I was trying to ask you, is BA defined?
Yes, sir.
You check
Yes,
the
sir.
two middle numbers. 2 is equal to 2, right? The two middle numbers are the same. These two numbers are the same. That's the condition when the multiplication is defined. And then the second question we need to answer is, what is the size? The product of two matrices is, of course, a matrix.
2.
I haven't talked about that yet. Okay. Again, the answer to the product is a matrix. And then, secondly, we are going to define the size of the product. We're talking about the size of the product. Now look at item number 2. Item number 2. If the product is defined, and then to define the size of the product, we have to determine how many rows in AB, how many columns in AB, right? Okay. Now look at that. The number of rows in the product is always the same as the number of rows in the matrix on the left. Mute your microphone, please. The number of columns in the product is always the same as the number of columns in the matrix on the right. By that I mean, what is the size of AB? What is the size of AB? In the second question, we are trying to define the size of AB. In AB, the number of rows is always the same as, that's right, 2 by 2. The size of the number of rows in AB is always the same as the number of rows in the matrix on the left, and the number of columns in the product is always the same as the number of columns in the matrix on the right. So the size of AB should be 2 by 2. I think everybody told me 2 by 2. Okay. It's 2 by 2. And also a shorter way, a simpler way to see what's going on. I want you to remember one other notation, okay? One other notation. If the two middle numbers are the same, then the product is defined. And then the size of the matrix, is the number of rows is given by that number, the number of columns is given by that number. You just remember something like this. So now let's say I'm still talking about item number 2. A is a 2 by 3 matrix and B is a 3 by 2 matrix. It's defined. The answer is defined. And then the size of the product, the number of rows. So mute our microphone, please. The number of rows in the product is given by the number of rows in here. You look at these two numbers. These two numbers will give you the size. It's 2 by 2. The first 2 is coming from that number. The second 2 is coming from that number. That's what we meant by the number of rows in the product is the same as the number of rows in the matrix on the left. The number of columns in the product is the same as the number of columns in the matrix on the right. You just remember something like this. And then you can determine the size of the product. Okay. We have answered 2 questions, right? And then at item number 3, of course, we need to figure out the numbers, the entries in the product. Okay. So how about we just compute AB? Okay. We just multiply 2 matrices with A on the left and B on the right. Okay. We mentioned AB is defined, and the size of AB is 2 by 2. If the size of AB is 2 by 2, then how many numbers are we looking for? If the size of the product is 2 by 2, how many numbers are we looking for? In a 2 by 2 matrix, there should be 2 rows, 2 columns. We're looking for 4 numbers, right? We're looking for 4 numbers. At this point, I'm going to label the 4 numbers using C11, C22, C12, I mean. C12 is the number located in the first row, the second column. I'm going to label that number using C21, I believe, the number located in the second row, the first column. I'm going to label the entry in the product at this location, the C22, the entry located in the second row, the second column, right? I'm going to tell you how to get the numbers. Probably I'm going to move it here. I will copy the matrices A and B. Okay, I think A is a 2 by 3 matrix, 2, 1, 3, 4, 0, 2, and B is the matrix 3, 1, 1, 2, 0, 1. I hope it's not too messy. Okay, now let's look carefully. The last question we need to answer is what are the numbers in the product? What are the entries in the product? What are C11, C12, C21, and so on? Okay. I will tell you 2 numbers. You tell me 2 other numbers. I will tell you C11 and C21. Okay. To get C11, you use the first row in the matrix on the left, corresponding to that one, and the first column in the matrix on the right. You multiply that row and that column. In this case, C11 is computed by multiplying the first row in matrix A, the first column in matrix B. If you want, I can write that in some more detail. Okay, the first row in matrix A is 2, 1, 3. Can I just bulk that? The first column in matrix B, that was 2. Right? You use the first row 2, 2, 1, 3 to multiply the first column 310. We mentioned how to multiply a row and a column, right? It's computed using 2 times 3 and then plus 1 times 1 and then plus 3 times 0. Anybody want to tell me the answer? I think 6 plus 1 is 7, right?
7.
I think it's 7. So thank you. I think that's 7. So later on in the product, C11 is going to be replaced with 7. I told you I would tell you how to get two numbers, and then you get me two other numbers. Okay. Now we are going to compute C21. To get C21, you use the second row in the matrix on the left, the first column in the matrix on the right. Now look at my mouse cursor and also look at the two matrices. I do not want to circle too many things. It could be a little messy, but to get C21, which is the entry in the product at the location, the second row, the first column, you use the second row in the matrix on the left, so which is 402. And the column you need to use is the first column on the right, right? The first column on the right is 310. Anybody want to tell me the answer to that?
12.
I think it's just 12, right? So later on in the product, C11 is going to be replaced with 7. C21 is going to be replaced with 12, right? I told you two numbers, so please, now I want you to take a little time to tell me two other numbers. C12, C12. I want you to compute C12 and C22. Okay, I will give you a little time.
C12 is 7.
Take a little time, I think. And then after you're done, so tell me two numbers. Write the two numbers in order. So tell me C12, C22, please. Write your answer in the chat, please. So tell me the two numbers in order, please. I don't know the answer. 6 is right, probably. I don't know. I need one other person to tell me the answer, please. Okay, now let's do this together. Okay, C12 for C12 you use the first row, the second column. I think C12 is 7 is probably right. C12 is 7. C22 please. C22 is 6. Okay, thank you. 6 is probably right. Okay, now we have the answer, right? Actually, it's pretty long procedure. You need to answer 3 questions when multiplying two matrices. 3 questions. Okay. The first question you need to answer is is the product defined? You use a trick like that. Okay. You check the number of columns in the matrix on the left. You check the number of rows in the matrix on the right. If the two middle numbers are the same, then the product is defined. And then you determine the size. The number of rows in the product is given by that number. Now look at the screen. The number of columns is given by that number. So the size of the product is 2 by 2. After getting the size, you will know how many numbers in the product you are going to get. A 2 by 2 matrix has four numbers, has 4 entries, right? And then to get each number in the product, to get each entry in the product, you use the corresponding row and the corresponding column. You always multiply a row and a column, you get all the numbers. That's how we compute the product of the matrix, the product of two matrices. Okay. We just did A times B with A on the left and B on the right, the product of AB. Okay, we'll move on to compute to do one other question. Okay. If I want you to compute the BA, so this time it's a multiplication, a product with B on the left with A on the right. You're going to see even the size of the product is different. Okay, yeah, that's why I told you this is probably the only operation you have seen or you are going to see. I guess many of you guys so do not do math major. If you do not do math major, I'm pretty sure that's the only operation you see, so which is not commutative. Okay. Later on, we're going to make more comments, but now we'll still go over the question together. Okay. So do not forget you need to answer three questions. Is the product defined? And then the size of the product, if defined. And then after that, you determine the product, all the numbers in the product. Okay. We'll label the questions one by one. Is the product defined? So by that I mean is BA defined? You use a trick, something like this. To answer that, you check the number of columns in B, you check the number of rows in A. On scratch paper, you could do something like this. B is a 3 by 2 matrix, right? 3 rows and 2 columns. And A is a 2 by 3 matrix. 2 by 3, I mean. And then you check the two middle numbers. If these two numbers are the same, then it's defined. So the answer is yes. And then the second question you need to answer is what is the size of the product? What is the size of the product? So write something on the chat, please. With B on the left, with A on the right, is 3 by 3. To get the size, I told you the trick. The wording in the definition is the number of rows in the product is always the same as the number of rows in the matrix on the left. The number of columns in the product is always the same as the number of columns in the matrix on the right. It's actually determined by these two numbers. So the size of the product is 3 by 3. Okay. And then we are going to get all the entries in the product. You told me the size is 3 by 3. Now we are looking for 9 numbers. We are looking for a matrix with the 3 rows and 3 columns. Okay. So maybe we do something like this. We use proper notations. Label these numbers properly. Yeah, it's kind of important actually. Okay. I'm going to use C11 to denote entry in the product at the first row, the first column, and so on. Okay, so this number should be C12. That number should be C13. We're looking for 9 numbers, right? And then C21, C22, and then C23. Again, label the numbers properly, so otherwise you could make some mistakes. Okay. So this time, I'm pretty sure I will see. I'm, I'm trying to say I want you to get the numbers yourself. So please, for instance, C11, you use the first row, the first column. C12, you use the first row in the matrix on the left, and the second column in the matrix on the right, and so on. So
Sir,
please,
your last in your last row there, you have C31, C22, C23.
sorry
Shouldn't it
about
be
that.
C3?
Yeah, so you're right. C. So this time B is on the left, A is on the right, B is on the left, A is on the right. Okay, you use the first row in matrix B. So what's the first row in matrix B? The first row in B is 3, 1. Right, and then you use the first column in matrix A. It's probably easier if I do something like this. Okay, to compute the BA, we let BA is something like this. So maybe we write B on the left. B is 3, 1, and the second row is 1, 2, 0, 1 in here, and A is on the right. A is the matrix 2, 1, 3, 4, 0, 2. Right. Okay. To get C11, you use the first row in the matrix on the left, the first column in the matrix on the right. That's how you get 10. You use 3, 1. You use that row to multiply the column to 4. So do you have 10? 2 times 3 is equal to 6. 1 times 4 is equal to 4. 6 plus 4 is equal to 10. Ben?
Yeah, I understand that now. I'm just wondering, so when you go to C13, then what number would you multiply it by?
C13, you use the first. Now let's work on the C13. Why not? To get C13, you use the first row. Okay. To get C13, you use the first row in the column on the left. Now let me start over. I said something wrong. To get C13, you use the first row in the matrix on the left. You use the third column in the matrix on the right, corresponding to that 1, that 3. So what's the first row in the matrix on the left? It's 3, 1, right?
Oh, okay. Sorry, I totally understand now. I just had it
Okay,
backwards at first in my
3, 3,
head.
2. That's how you get what the number again? That's I forgot the number. 8?
11, sir.
Yeah, that's 11. Yeah, sorry, that's 11. Okay. Again, the answer, the answer, the answer is on this screen. Okay. Any questions? Any other questions? If you don't have any questions, then we move on to the more things, to the more questions. I mean, okay. I think we did part two. We did part two. We computed AB. We computed BA. We answered question C. Is the matrix multiplication commutative? So the answer to C is no, right? In general, matrix multiplication is not commutative. If you don't have any questions, we'll move on to question 2. I will copy question 2 in the chat. On PowerPoint, I mean. Good enough? Now let's do question 1 together, and then So how about we do many questions together? Okay. Now question A. We'll work on question A together. Okay. We're trying to compute AB. This time I'm going to write the size of the matrix. For you guys, it's imaginary things. You imagine the sizes. I'm going to write it down. Actually, it doesn't matter. You write it down. Okay. A is a 2 by 3 matrix, and the B this time is a 3 by 3 matrix. Now look at B. B has 3 rows and 3 columns. B is a 3 by 3 matrix. Okay. Is the multiplication defined? Is AB defined? You check that and that, right? If these two numbers are the same, then the multiplication is defined. After convincing yourself the multiplication is defined, and then we determine the size of the product. So this time you write AB in here. We're trying to get the size of AB. You put the brackets here, okay? Now the size of the product. The size of the product, please. Anybody want to write something in the chat? The size of the product. The size of the product is, you look at this number. That number gives you the number of rows. This number gives you the number of columns. No, 3 by 3 is not right. The number of rows is always the same as the number of rows in the matrix on the left. This number gives you how many rows in the product. The number of rows is 2. Okay. And then the number of columns in the product is 3. So the product is going to be a 2 by 3 matrix. Right, 2 by 3. By that we mean we are looking for a matrix with the 2 rows and 3 columns. To answer question A, we are looking for a matrix with 2 rows and 3 columns. So this time I'm going to copy A and B. You have 2, 1, 3 in here. I'm trying to copy the matrix A. Okay, so 0, 1, 2 here, right, in the second row, and the B is the matrix 3 by 3 matrix. 4, 1, 2, 3, 1, 5, and then 2, 0, 1. Okay. And then after that, we're getting the size. We're going to, if you show all your work, we're going to, we're looking for 6 numbers. Where the product is going to be a 2 by 3 matrix. You write something like this: C11, right? C12, 2 rows, 3 columns. C13, I believe the second row. C21, C22, and C23, right? Now we are looking for 6 numbers. I will give you a little time, and then you tell me the answer to that. I will give you 5 minutes. 5 minutes, please. Actually, after you get the final answer, I want you to tell me the first row first. And then in next line, you tell me the 3 numbers in the second row. And then we compare answers. Okay, so please. Actually, in many cases, it's not too hard to do it mentally. So now let's say to get C11, you use the first row here, you use the first column here, right? You multiply the first row and the first column. You compute 2 times 4 plus 1 times 3 plus 3 times 2. I think you have 8 times 8 plus 3 and then plus 6.
17.
17 here. I think. So please, after you're done, write your first row in the chat, please. I will put a question mark here. I need one other person to confirm the answer. Okay, you keep on working. I will show you the answer. Yeah, probably it's time for me to show you the answer. I'm pretty sure I have the answer to the question in the notes. That one should be the answer to the question. Is that right? Okay, now look at this. Now look at the screen. I think I shared the screen properly. So you have the answer to AB on the screen. We're done question A. We're done question A. Okay. In the future, if you really know what's going on, if you really know what's going on, you do not have to write C11, C12, and so on. You can just go from. I'm trying to say, it's okay to remove that. It's permissible to go from here to here as long as you really know what's going on. But in any case, you need to answer three questions. Is the product defined? And what is the size of the product? You have to answer the questions anyway, right? And then you can get the final answer.
I just have a quick question. You have, for the first row, you have 17, 3, and 14. But for 14, isn't it 4 plus 5 plus 3? So that'd be 12?
Who told me 14? Yeah, that's probably you're probably right. You use that row to multiply that column. It's 4 plus 5, then plus 3. It's 12? Sorry. Sorry, it's weird. It's not selecting. I think you're probably right. Who told me for 14? It's 12, right? I think 12 is right. You have the answer here. Okay, thank you, Tyler. Okay, I think all of you guys got it. Yeah, that's how we answer question A. And then we move on to question B. Okay, we move on to question B. This time I still use the trick I told you. To multiply BA, I want you to write down the sizes. Okay, B again is a 3 by 3 matrix. Okay, and A is a 2 by 3 matrix. It's a little bit too far apart, but I was trying to write BA, okay, the product of BA. This time the multiplication is undefined, so because this number is different from that number, right? So which means the number of columns in the matrix on the left is not equal to the number of rows in the matrix on the right. In this case, it's not possible to define the product of the two matrices. You just say the answer is undefined. Okay. Simple enough. If the answer is undefined, so of course, so there's no product. You do not have to move on. Does that make sense? I'm trying to say in the future, so do not tell me the answer is undefined. The product is undefined, and then you keep on computing the numbers. It's undefined anyway, right? Somewhere than this. Now compute the AC, please. I think AC is defined. I will give you a little time to do AC, please. After you're done, write the answer row by row. I will show you the answer very shortly. Actually, you could move on to C and D. So do not do E, okay? Do not do E. E and F are a little bit long. Now I want you to do C and D, okay? After you are done, write your answer on the screen, please. Row by row, please. Row by row, please. Gardeep, I'm looking for the second row. The second row, too, please. On the screen, you have the answer to AC. I think you guys got it right. You guys got it right. You guys got it right. Okay. Okay. If you have any trouble, take a picture of the screen, so you have the answer to AC. Okay. So do not do 4. I know it's a little bit long to do 4, but I'm going to make some comments on 4. Okay. In question 4, I want you to compute. I think 3 should be simple. 3 should be simple. Question 3 should be simple. BI is the same as B. IB is the same as B as well. Later on, I'm going to make some comments. Do not do 4, but I want to mention the meaning of 4. The order of operation is the same as numbers. You also remember something like this. I think the order of operation is bad math, right? For the people who do not know the meaning of that, so anybody want to tell me the meaning? So B for brackets, E for exponents, right? D for division, M for multiplication, A for addition, S for subtraction. Okay, the order of operation is also the same. I'm trying to say if you see brackets, you compute the stuff inside the brackets first. The meaning of E and F are different. In question E, you compute the product of AB first with A on the left, and then you have a new matrix, and then you put the product on the left, and then you multiply the product by C. And likewise in question F, you compute BC first, and then on to the left of BC you multiply A. Okay. I'm trying to say compute the stuff inside the brackets first. I guess you know the meaning. For E and F, we do not have time to complete this, so do not compute that. Okay. You should end up with the same matrix. Actually, it's not a surprising answer. It's true in general. Very shortly, I'm going to make some comments on the properties. Okay. It's 30 now. Now I'm going to make some comments on the operations. On the screen, I is called a identity matrix or unit matrix. To get identity matrix or unit matrix, it's always a square matrix. By square, I mean the number of rows is the same as the number of columns. I is a 3 by 3 matrix, right? In which, now listen to me carefully. I believe you can see how to form that. All the numbers on that diagonal is called the main diagonal. All the entries on the main diagonal are ones, and all other numbers are zeros. If you see a matrix like that, it's called identity matrix or unit matrix. Why we call it unit matrix? Now look at question 3. In question 3, it says for a unit matrix, any matrix, actually B times I, and I times B, no matter I is on the left or on the right, it's always the same as B. Anybody want to tell me this I is comparable to what number in number multiplication? I want to repeat my question. This I, the identity matrix or unit matrix, I is comparable to what number in number operation? It's comparable to 1. So that's the answer I'm looking for. In number operation, 1 times 1 multiplied by any number is equal to any number. It's comparable to that. The property is true in general. You multiply identity matrix I on any matrix as long as the multiplication is defined. The answer is always the matrix. I'm trying to say BI times IB is equal to B. The property is always true. Okay. That's why we call it identity matrix. Represented by question 4. We did not compute that, but you just assume the answer is right. This property is true for any 3 matrices as long as the multiplication is defined. We call the property associativity. Probably for this course you do need to know some terms. On next screen I'm going to summarize some properties. Okay, I will copy the properties on PowerPoint. I'm going to make some more comments. I probably will have time. These are the properties of matrix multiplication and other operations. I will tell you some terms. I just told you this property, the first one is true for any 3 matrices as long as the multiplication is defined. This property is called matrix multiplication is associative. Or simply you can call it associativity. Okay. The second property is the property of I. I is called the identity matrix. Okay. Again, I is comparable to the number 1 in number multiplication, in number operations. It's a multiplication unit. Yeah, that's why we call it a unit matrix. Identity, it means it's comparable to 1. Okay. We do not have time to do the next question, so this one is probably on your quiz. Again, on Friday you're going to have a quiz. Okay. But the next property, I will give you a name. Okay. I told you to multiply to perform the operation inside the brackets first. For this one, you add the 2 matrices first, and then you use the sum to multiply C. It's the meaning is different on the right hand side. On the right hand side, you compute 2 products first, and then you add the products, right? But the property, I will give you a name. The name is matrix addition. Matrix multiplication is distributive over addition. It's something like this. For numbers, we call that property multiplication is distributive over addition. Okay. Comparable to that, we say matrix multiplication is distributive over addition. You know the meaning of the property. You want to be able to say it in using proper term. The next property has no names. It's kind of associativity if you have a scalar multiplication and a matrix multiplication together. Okay. It's also called associativity. The last one is you see a big O. A big O in here. A big O is actually called the zero matrix. Easy to define. The zero matrix is a matrix in which all the numbers are zeros. All the entries are zeros. Okay. I believe you can imagine, as long as you have one factor which is the zero matrix, the answer is going to be the zero matrix, as long as the operation is defined, as long as the multiplication is defined. In this case, 0 is comparable to number 0 in number operation.